Greetings. Now we are going to discuss triple integrals in cylindrical coordinates. Cylindrical. So what does that mean? Well, let's think about what we have been discussing and talking about polar coordinates. And when we're dealing with polar coordinates, we're generally dealing with a circle. If we take that circle and extrude it into a third dimension, we create a cylinder. So let's review 2D polar coordinates just to make sure we know where we are. We have some point here, P, XY in our XY plane. And thinking about that point, instead of considering it as the X value and the Y value, right, because we have a horizontal X and vertical Y, we can think about that as being a directed angle rotation theta, and then some directed distance out from the origin r. So we could also refer to that point. We could say P is some point r comma theta. All right, so now let's take this and transfer that polar equation, polar coordinate logic into 3D. So we have my X, Y, and Z plane. So we think about this, and this is my positive x-axis. So I have a positive rotation, theta, in space, out a directed distance, r. And so if we think about this that I just drew here, this angle, r, as part of a cube, in a sense. All right, so I'm just drawing a cube to help us visualize this. So we travel some theta rotation and then out some r value, and then we go up to some point in space z. So in this case, when we think about taking that rectangular or polar coordinate in 2 dimensions and then putting it into 3 dimensions, we now have this point in space. We rotate, we extend out, and we shift up. So that gives me a polar point, r theta z, which is the same as some rectangular point, x, y, z. So we extend, or we rotate theta, we extend out r, and then we move up z. I feel like that looks like a x. It is a z. Okay, so the conversion formulas, we already know this. If we are traveling in cylindrical and we want to, traveling or considering cylindrical and we want to convert that into rectangular, we're going to use the same things we already know about this relationship between polar and rectangular. We'll say x equals r cosine theta, y equals r sine theta, and since z is just a vertical distance up, z is just going to equal z. So we have that set there. And then from rectangular back to cylindrical, we can write these a little differently. We tend to use x squared plus y squared equals r squared, which we already know. Tangent theta equals y over x, and then also again, z equals z. All right, so let's just jump right in to an example. In this example, we're just going to make sure we understand how to relate that cylindrical coordinate to the rectangular coordinate system. So we're going to plot this in 3 space, and then we're going to convert it into rectangular form. So thinking about what we know, this is r, theta, and z. And my z value is just going to be the same, but I need to still convert r and theta into x and y. Before we even start that, let's think about graphing this. Okay, so we have our x-axis, we have a angle of rotation 2 pi over 3, which takes us into quadrant 2, which is going to go about right here. Then we are going to extend out a distance or a radius of 2. And then that creates a circle per se. So we have this 2 radius circle. If we continued drawing that around there, this isn't perfect. And we're going to extend on that circle up 1 unit because that's my z value. So this is my point in 3 space, and it's easier for us to visualize if we think about that as being located on this right circular cylinder here. Doing a smashing job of drawing that, I think. All right, so thinking about this as a cylinder in space of height 1, we are, when we do that angle, rotation, extend out from the origin, and then shift up 1 unit, we're ending up at this point in space. And converting that, we have x equals r cosine theta, y equals r sine theta. So I'm going to have 2 times the cosine of 2 pi over 3 and 2 times the sine of 2 pi over 3. We know both of these values on our unit circle. Cosine will be negative, sine will be positive. Going back to pi over 3, we know the ordered pair there would be 1/2 root 3 over 2. So cosine of 2 pi over 3 is negative 1/2. Sine of 2 pi over 3 is root 3 over 2. So simplifying each of these, I get that x equals negative 1 and y equals positive root 3. So my new rectangular coordinate here is negative 1 root 3, and then my z value is still the same, which was given as 1. Let's just do one more example to make sure we understand going in the opposite direction. In this example, we are going to convert the rectangular ordered triple 3, -3, -7 into cylindrical coordinates. So we are given an x, a y, and a z. We want to remember the other formulas we use to help us convert. One that is helpful is tangent theta equals y over x, opposite over adjacent, and then r squared equals x squared plus y squared. All right, so first let's deal with tangent theta, finding our theta value. That would be that tangent theta equals -3 over 3 is -1. So we know that tangent is equal to 1 at my pi over 4s. And so that's going to tell me, and if we're dealing with 1 unit circle rotation, that's going to be either negative pi over 4 or positive 3 pi over 4. Keeping in mind negative pi over 4 is the same as 7 pi over 4. All right, so we've got 2 theta values. Now it's only going to be 1, so we want to also consider our figure to choose which one. So I've drawn this in 3 space. I find sometimes when you're visualizing, it helps you to kind of draw the invisible cube that this is on the corner of. Well, not cube, prism, I should say. But we go out +3, back -3, so +3, -3, and then we went down 7. So we're down here, and if we think about that as a rotation up here, we are in this 4th quadrant. So that means we're going to choose negative pi over 4, not 3 pi over 4, because 3 pi over 4 would have ended over here in quadrant 2. So negative pi over 4 is going to be my angle. Looking at calculating r squared equals 3 squared plus -3 squared. R squared equals the square root of 9 plus 9, which is 18. And the square root of 18, we can pull a 9 out. That's going to be 3 root 2. So my ordered triple in cylindrical coordinates would be r, 3 root 2, theta, negative pi over 4, and then the z value stays the same. It is negative 7. So I hope that helps you think about or visualize a little bit better what cylindrical coordinates are and then how we can convert between. Um, Email me if you have questions, comments, concerns, you find an error, anything. I'm here. Contact me. All right, have a great day. See you in a couple seconds.